Weird.
That's my homemade motor based on wire on a cork. And what'd you call it? Weird?
Weird.
Weird? Doesn't look weird. It looks like an ordinary motor to me.
Doesn't look like it's...
But that's your word for great, good, or something weird?
Yeah.
Okay,
right.
I will accept it as a compliment. You can build one of these yourself out of stuff you can sort of find around the house, but first I think you should make sure that you understand the principle of what makes a motor work. See that magnet over there?
Yeah, this one?
Right.
That one.
Well, this one's sitting on a turntable so it can spin around. If you bring the north pole of one magnet near the north pole of another, what happens?
It repels.
Yeah, it repels it. Then you can see this turns. If you now bring the south pole around like that, it's going to give it another spin.
Oh, weird.
See how you can get it to spin? See if you can get it to go. Because that's the principle of the motor. A spinning magnet and one that you can change polarity.
Right.
And when you can get them in the right sequence, why you can get the other one to spin. Okay, let's now take a look at this one, because this is a sort of a real motor. You want to put that over there? Thank you. This time, the current's going to come through here through my power supply and go through there. What will that make that into?
That'll make it into an electromagnet because like there's a lot of coil of wires, and when an electrical current goes through lots of coils of wire, then it makes it into an electromagnet.
Not only that, but see how this is curved around out here? The magnetism is going to come up. This is all going to become a magnet, and so is that.
Oh, neat.
Then here, I'm going to use my paintbrush as a pointer because the important part is going to be kind of hard for you to see, and I want you to be able to see it. First of all, the easy one, where is the magnets that spin?
Right, on there.
Yeah. They're electromagnets too, because there are coils there, see?
Right.
Now, what does the word commuter mean, you know?
It means like somebody that gets on a train and goes to work and then comes back again at night.
Back and forth and back and forth.
Yeah.
Well, it's the same root of the word, but it's called a commutator in this case. The thing that reverses the polarity. And you see this right down in here, the shiny part right there? Mm-hmm. Okay, there's a little piece of metal that rides against that, so current can go through there to make this into electromagnet. Now watch. See it goes through a slot there? Mm-hmm. Okay, now it's making contact with this, and that makes this into a magnet.
Right.
Then the next one comes around, there it went by the slot, and that makes, now you can make this into a magnet. So that's reversing the polarity, and that's why it's called a commutator.
Right.
All we have to do is add a little current.
And turn it on.
And away it goes.
Oh, neat.
Now see if you can find the important parts of a motor right here, because this is from an actual real motor, but I took it apart so that you could see the important parts. First of all, where's the spinning magnets?
They're the ones that like, yeah.
Right down
ones,
here, right?
Yeah. And then there's the coils of wire
Right.
for the
Okay.
electromagnet.
Then here's the commutator in this case. See that little black thing right there?
Mm-hmm.
Well, that's a carbon brush, a hunk of carbon. Current can come up through here, and now the carbon touches this part right here. Current can come up on the other side and touch that one over there. So that's how the current is reversed as this spins.
Oh, neat.
See? What's missing?
The stationary magnet.
Okay,
The one that...
there's one right there. I'll turn on the current. You hold the magnet up above.
Oh, weird, like you can feel the electricity. Will it work on the south side?
Try it.
Oh, weird, it goes the other way.
Sure. Okay. Now that you know all the important parts of a motor, come on around over here and see if you can just figure out how to build one of your own.
Okay, first of all, you need the stationary magnet that's down there.
That's the round magnet down below here, right?
Right.
Okay.
And then you need the electromagnet, like
That's
the ones that spins
the spinning
around.
magnet, that's going to spin right there.
Yeah.
Right.
And then there's the source of electricity,
Right.
right? And then here's the wires that come up.
Right.
And then
What's missing?
the commutator.
Yes. Let me show you. This is a very clever thing that my friend Bud Wentz put together. See that wire down there?
Mm-hmm.
Well, part of it's dark. See how it's dark on one side? Mm-hmm. That's enamel, which works like an insulator. But we scraped off part of it, so when you turn it the other way, you see how it's scraped off and it's shiny? Mm-hmm. Well, that means current can flow whenever the shiny part is touching the top of this end of the safety
So
pin.
it's like a pulse.
So, yeah, a current can go through here and give it a pulse. It goes down here through the other side. Then when it's like this, no current goes through. Then when it comes around again, current goes through. So that's the secret of this homemade motor. Connect it up. See if it'll actually go now.
The other side is connected up?
Yep. Go ahead. Give it a little... There you go.
Neat.
So you can make your own homemade motor with a permanent magnet, a cork, a coil of wire, a safety pin, and a battery.
I'm going to make one of those at home.
Good.